z minus 3 cos z over z minus pi by 2 whole square dz over the circle mod z equal to 2. Before moving on to the solution, let's recall first the Cauchy's integral formula. So first one is Cauchy's first integral formula. Suppose this is a circle C having the point, let's say z0, this point, right? What can you say about this point? This is the point at which this complete integrand is not defined, right? So if you put the denominator equal to 0, you get z equal to z0. So if the z0 point lies inside the circle, then we apply the Cauchy's integral formula for this, right? So the formula is f of z0 equal to 1 over 2 pi iota integral of fz over z minus z0 over c dz, right? If you notice over here, the power of the denominator is 1, right? So we apply the Cauchy's first integral formula for this. If the power of the denominator is greater than 1, then we apply the another Cauchy integral formula, which is nth derivative of fz at z0 equal to n factorial over 2 pi iota integral of fz over z minus z0 the power n plus 1 over c dz, right? Suppose the denominator is having the power 2. Then what is the value of n here? Here n is, yes, 1 plus 1, that is n is equal to 1 over here, then only the power becomes 2. Let's move on to the solution now. The given integral is z minus 3 cos z over z minus pi by 2 whole square dz for the circle mod z equal to 2. So first we have to check the point. And how can we get the point? By taking the denominator equal to 0. So on putting the denominator equal to 0, we get z is equal to pi by 2. This is the point z0. Right? Let's check this point lies inside the circle or not. Now what is pi by 2? If you put the value of pi as 3.14 over 2, it is approximately equal to 1.57, which is strictly less than, the radius is 2 over here. So this is strictly less than 2. Hence we get that this point lying inside the circle. Right? So what is fz? Fz is z minus 3 cos z. And because I am having the power of the denominator as 2, I have to apply the second Cauchy integral formula for this, right? So it is right written over here. I'm just revising the formula. N a derivative of f of z at z0 equal to n factorial over 2 pi iota integral of fz over z minus z0 the power n plus 1 dz. Now here the power is 2, so n is, from here we get n equal to 1. And what is z0? Z0 is pi by 2. Right? So we need here, okay, this becomes, for n equal to 1, this becomes the first derivative of the function at z0. So we need f dash z also, right? So let's calculate the derivative of fz. That is 1 plus 3 sine z. And the value of this first derivative at z0, that is pi by 2, this is equal to, just put the value of z as pi by 2 over here, we get 1 plus 3 sine pi by 2 is 1. So this is equal to 4. Now this function is analytic inside, within the circle and on the circle, right? The derivative of this function exists at all the points of the circle, within the circle and on the circle. So we write that since fz is analytic within the circle and on the circle, and z0 equal to pi by 2 lies inside the circle. So by Cauchy's integral formula, integral of z minus 3 cos z over z minus pi by 2 whole square for this circle, this is equal to, okay, this is your fz. So writing here fz. And now according to this formula, this is your fz and this is your z minus pi by 2 whole square dz. Just take 2 pi iota to the other side and n factorial to the denominator of this numerator of the left hand side. So from here we get, so this is 2 pi iota over 1 factorial into the first derivative of the function at pi by 2. So this is equal to 2 pi iota, and we have calculated this value as 4. So this is into 4, that is equal to 8 pi iota. Hence this is the required answer. Thank you.